The term ventilation refers purely to the movement of air. It does not refer to the exchange of gases like oxygen and carbon dioxide. I have pictured here a fan, right? A fan only moves air, similar to the process of ventilation. I also have pictured here a protist, which is a one-celled organism that is essentially a parasite. It gets delivered to humans by way of a mosquito bite from a mosquito that's specifically carrying the eggs of this parasite. All good things come to humans by way of mosquitoes. The parasite eggs, they then grow and multiply in your blood because you're the perfect temperature. And this genus of protists is called Trypanosomus and is known to cause something called sleeping sickness. There are different species of Trypanosomus and there are different versions of sleeping sickness. Basically, this little protist loves to wrap itself around your red blood cells and hug them so tightly that they burst. So as you sleep, you keep ventilating, moving air in and out of your lungs, but all of the oxygen that you could get during external or alveolar respiration, it never gets picked up and it never gets delivered to your cells. Listen to yourself take a few breaths. Right now, you're probably doing quiet breathing if you're sitting and studying. If you're exercising and listening to this, you're probably doing what's called forced or active breathing. I did not assign these names based on your state of exertion. They are assigned based on the use of the muscles that you use to achieve the type of breathing. In quiet breathing, which is pretty much what you do all the time, you are only using your diaphragm, which is a parachute-shaped muscle that separates your thoracic and abdominal cavities. And you are also probably, well, you are definitely using these external intercostal muscles, which are the muscles between your rib bones. You use these two muscles for inhalation. You don't use anything for inhalation. Nothing. When you are quiet breathing, the elasticity of the lung and its ability to recoil works in exhalation so you don't have to make any muscles work to exhale. That is quite efficient. So active or forced breathing is when you continue to use the diaphragm and the external intercostal muscles to inhale. However, you might be using some accessory muscles to aid the diaphragm and external intercostals. The muscles you use in quiet breathing to inhale, those are called your primary respiratory muscles. Diaphragm, external intercostals. The additional muscles from the neck, like the sternocleidomastoid, or the scalenes, like the chest muscle, the pectoralis minor, or like the belly muscle, the rectus abdominis. You can use all of those to inhale and exhale, and those are called accessory muscles. You can recruit them to help. You don't need to consciously recruit these muscles. There are centers of your brain that will control respiration and recruit these muscles as needed. So if you have asthma, you might be breathing using your accessory muscles. You just may not realize it. It is possible to be doing active or forced breathing and not realize it. In conditions like asthma and bronchitis, accessory muscles from the neck are usually recruited to do the breathing that overcomes asthma and bronchitis, but not in such a way that you would notice it. Many times people will say like, oh, my neck hurts just a little bit. These accessory muscles in active or forced breathing, they can contribute to the work of the diaphragm and the external intercostals in expanding the volume of the thoracic cavity. These accessory muscles can also be used in exhalation. But remember again, there are no primary muscles for exhalation, right? Because that happens simply due to elasticity. But I can use these accessory muscles during forced or active breathing to exhale. I guarantee that what I explained in the previous slide makes sense now, but I'll soon make it a little bit more complicated. Let's give a few things some abbreviations so we don't have to keep writing it out in our notes. So Dalton's law told us about the partial pressures and the combined pressure in the atmosphere. Let's call that big P ATM to indicate the pressure of the atmosphere. There is also pressure in the alveoli of your lungs. And I'm going to make that P pull, not people, but P pull. And this can also be known as the intrapulmonary pressure, the pressure inside your little alveoli. But I'm not going to leave it there. To make things even more complicated, we also have to consider the pressure that is in the intrapleural space, which I like to call PIP. So we have people and PPIP. Anyway, no, we don't have any air in the intrapleural space. Remember that it's a closed cavity bounded by the pleura, but I will use this space to create a pressure gradient when I inflate the alveoli. So here is something very important to remember. You cannot manipulate pressures at all. You can't do that. You especially cannot manipulate atmospheric pressure, right? You have no control over that. But you can manipulate the volume of your lungs. So do that right now by taking an extra large breath or exhaling for just a few seconds longer. You are controlling the volume of your lungs. And even though you can't directly change the pressure in your intrapulmonary spaces, the alveoli, you can, according to Boyle's law, you can control the volume. And whatever you do, there will be an inverse effect on pressure in the intrapulmonary space. So before now, we have been looking at pressure measurements that are millimeters of mercury. However, we're now going to kind of move over to millimeters of water. And your book provides a really nice explanation as to why we work in millimeters of water. And part of it is because when we do respiration tests like that, we can see smaller changes in a column of water than we can in a column of mercury. So that's why during this chapter you may see this unit of measurement. It just means pressure.